I'm Anil Kumar. Welcome to my series on arithmetic progression. Here are 6 questions from one of our subscribers. Let me thank her for posting these questions, and I hope solution of these will help many others. Question number 1. The sides of a triangle with perimeter of 30 cm are in AP. So I've used AP for arithmetic progression. If the difference between the longest and the shortest side is 4 centimeters, find all the sides of the triangle. Question 2. Find the ninth term from the end of the AP 5, 9, 13 till 185. Question number 3. Is 0 a term of the AP 31, 28, 25 and so on? Justify your answer. Question number 4. The sum of first 3 terms which are in an AP, arithmetic progression, is 33. If the product of the first and the third term exceeds the second term by 29, find the terms. Question number 5. In a flower garden, there are 23 plants in a row, 21 plants in the second row, 19 plants in third row, and so on. If there are 10 rows in the garden, then find the total number of plants in the last row. Question number 6. How many terms of the AP 65, 60, 55 will be taken so that their sum is 0, right? So I hope the questions are absolutely clear. You can pause the video, answer these questions, and then look into my suggestions. Let's begin with the solution of the very first question, which is the sides of a triangle with perimeter of 30 cm are in arithmetic progression. So let's take a triangle here. Let's say this is the triangle whose sides are in arithmetic progression. That is to say, if one side is x, the other one will be x plus d, the common difference, and third will be x plus 2d, right? What we are given here is that the perimeter is 30 centimeter. That is to say, x plus d plus x plus 2d is equal to 30 centimeter. If the difference between the longest and the shortest side is 4 centimeter, that is also given to us. That means difference between these two sides, right? So this side and this side is 4 centimeter, right? Then find all the sides, right? So let me just simplify this equation. There are 3 x's and 3d. So we get 3x plus 3d equals to 30. Or dividing by 3, we get x plus d equals to 30 divided by 3, which is 10. So we get one of our equations. Let me say equation number 1 from the first condition. The second condition is that difference between the longest and the shortest side is just 4 centimeters. So that is to say, x plus 2d minus x is 4 centimeters. So that means 2d is 4, d is 4 divided by 2, which is 2. So we know what d is. Now it is easy to find all the sides, correct? So we'll use the value of d as 2. We'll call this as equation 2. Substitute this value d here and find x. So we have x plus 2 equals to 10. So that means x is 10 minus 2, which is 8. Since d is 2, we have 8. The other side is 8 plus 2, and the third is 8 plus 4 as expected. So the answer is 8, 10, and 12. Units will be centimeters. Correct? So that becomes the answer for the given question. So I hope that is absolutely clear. Now let's take the second example, which is find the ninth term from the end of the AP 5, 9, 13, 185. So now we have to find the ninth term from the end, right? So let's rewrite this arithmetic progression. So we are given 5, 9, 13, so on till the last term, which is 185. Since we have to find the ninth term from the n, what we can do is we can write this in reverse order. So at present, you see, it is actually increasing by 4, right? So if you see from here, it is like plus 4. But if we reverse, right? So if I reverse this sequence, what do we get? We get 185. Then we have to decrease by 4, right? So 185, 181. So we have to decrease by 4, correct? Till the end, which is 13, 9, and 5. Do you see that part? So earlier, we were seeing in one direction. Now, since we need the ninth term, we can actually write it in the reverse order where they are decreasing by 4. Now it becomes simpler to get the ninth term using the formula, right? So here we have A as 185, common difference D as minus 4, and what we need to find is the ninth term, right? So this is what we need to find. Using the formula, we can straight away get the ninth term. So what is the ninth term? So let's write down the formula here, and then we'll substitute the value. Correct? So we know the ninth term will be A plus n minus 1 times D, right? So n is equal to 9. So substituting 185 for A plus 9 minus 1 and D is minus 4, we should get the ninth term, correct? So which is for us 8 times minus 4, 185 minus 32. So if you take away, we get 3 here and we get 5, 153 as your answer. So therefore, we have our answer as the ninth term is 153. Correct? So that is from the reverse order. So I hope that concept is absolutely clear. So now let's take up question number 3. Question number 3. Is 0 a term of AP? 31, 28, 25 and so on. You need to justify your answer, right? So this is an arithmetic progression. Let's rewrite the terms. 31, 28, 25 and so on. So as you can see, the arithmetic series is decreasing by 3, right? So we have minus 3. So in our series, we have the value of A as 31, D as minus 3. We need to figure out if 0 is a part of this series, right? So if 0 is a part of series, we can use, it will be some term, so we don't know which term it is. So let us say nth term is 0 for us. So we have A plus n minus 1 times D. And we want this term to be 0. So we want this to be 0. A is 31 and we don't know which term it is. So we are going to substitute the value of A and D and then find out what n is. So I hope the concept is clear. So now let's do the calculations. If we get a whole number value, then it is a part of the series, otherwise it is not, correct? So let's solve it. So we have 31 and this gives us, let's open the bracket, minus 3n and that becomes plus 3. Bringing 3n to the left side, we get 3n equals to 31 plus 3, 3n equals to 34. So n is 34 divided by 3. This is definitely 11 point something, right? So 11.3 recurring. So n cannot be a number like that. It has to be a whole number for 0 to be in the series, right? Therefore, 0, that is to say 0, is not a part of this arithmetic progression, correct? So that is how we are going to show that 0 is not a part of this arithmetic progression. Question number 4. The sum of first three terms which are in arithmetic progression is 33. So let the terms be x, then we have x plus d and x plus 2d. So the first statement is their sum, which is x plus d plus x plus 2d, should be equal to 33, right? If the product of the first and the third term exceeds the second term by 29, find the terms. That is to say, product of these two, right? So let me rewrite here. X times x plus 2d, that is the product, exceeds the second term, x plus d, by 29. So that gives us another equation. So we have two equations and two variables. We should be in a position to solve. Let us see how we can solve it. So again, we have 3x plus 3d equals to 33. Dividing by 3, we get x plus d equals to 11, right? Now on this side, let's open, we get x squared plus 2xd equals to x plus d plus 29. So we can actually do some substitution. Since we have x squared here, let's write d in terms of x. So we get d as equal to 11 minus x. So let me call this as our equation number 1, and we are going to substitute this in 2. So we'll sub equation 1 in 2 and then solve, right? So d is 11 minus x. So I'm writing d as 11 minus x. We have x squared plus 2x and then 11 minus x equals to x plus 11 minus x plus 29. Does it make sense to you, right? Open the bracket. We get x squared plus 22x minus 2x squared equals to x and x cancel. We have 11 plus 29, which is 40. Now here we get 22x minus x squared equals to 40. Taking all the terms to the right side, because 0 equals to x squared minus 22x plus 40, right? So 40 is 20 times 2, both negative, x minus 20 times x minus 2. So we get the value, two different values of x here, right? Okay. So one possible value is x equals to 20, the other value is x equals to 2. So these are two possible values. So if for which the condition is as shown here. So if I write 2 as my value of x, what do I get? So if x equals to 2, the first three terms will be 2 and the value of d. Let's find the value of d also. If x is 2, then d is equals to 11 minus 2, which is 9, right? So for x equals to 2, d equals to 9, correct? Now if I write x as 20, right? So we'll get two different answers. So for x equals to 2, we get d equals to 9. Let's say like this, okay. Now let's write down, if x is equal to 20, in that case d equals to 11 minus 20, right? 11 minus 20, and that gives you minus 9, right? So that is the second option. It gives you minus 9. It says the sum of first three terms which are in arithmetic progression is 33. If the product of the first and the third exceeds the second term by 29, find the terms. So let's find the terms and then we'll figure out whether both are valid or not, correct? So that is how we are going to do it. So in the first series, we are taking x as 2, d as 9. So the terms will be 2, and then when you add 9, we get 11, and again adding 9 gives us 20. Do you see that? So they become your first three terms. Now if I start with 20 and take away 9, I do get 11 and then 2. Perfect. So we get the same series, correct? So that becomes the solution. So the first three terms of our series could be either 2, 11, 20 or 20, 11, 2. Both are correct answers. Perfect. So that is how you are going to solve question number 4. It's kind of very interesting and an excellent question from previous test paper. Now let's look into question number 5. Question number 5. In a flower garden, there are 23 plants in the first row, 21 plants in the second row, 19 in the third row, and so on, right? So let's make a kind of table here. So, which gives you row number and plants, number of plants, let's say. So in the first row, we have 23 plants. In the second row, we have 21. And then in the third row, we have 19. And this series is actually going down by 2 each time. Correct? So that becomes the pattern. Now, if there are 10 rows in the garden, then find the total number of plants in the last row. So if this pattern is being followed, then in the 10th row, we need to figure out how many plants are there. Is that okay? So clearly, A, the first term here is 23. D, the common difference is minus 2. And the formula, which is an or term number, you can write an also. Nth term is equal to a plus n minus 1 times d. In this case, we want to find the 10th term. So n equals to 10. So 10th term will be 23 plus 10 minus 1 times minus 2, right? You need to calculate this to find the answer. So which is 23 plus 9 times minus 2, or 23 minus 18, right? So 23 minus 18 gives you a value of 5. So in the last row, there should be 5 plants, correct? So that is our answer. So in the last row, there will be 5 plants. Okay. Now let's get to question number 6, which is also the last question. How many terms of the arithmetic progression 65, 60, 55 be taken so that their sum is 0? So this is based on the sum of arithmetic progression, and the formula for sum is, see, we are given the first term, right? And we do not know how many terms. We have to find that. So we could use the formula n by 2 times 2a plus n minus 1 times d, right? Where n is number of terms. So in this formula, very important to understand, n is number of terms. A is first term. D is common difference. And Sn is sum of first n terms. Perfect. So that is the formula which we are going to use and find when will this sum be 0, right? Since we want the sum to be 0, I'm going to substitute 0 here for this sum. We don't know what n is. We'll try to figure this out. But we know what is the value of A. A is 65, right? So the first term we know is equal to 65. The common difference is minus 5, correct? It is going up by minus 5. So 2 times 65 plus n we don't know, and common difference is minus 5. Perfect. Now we can multiply by 2, so we get 0 equals to n times. In the bracket, we get 2 times 5, 10, 130. And this gives you minus 5n plus 5. Or we get n times 130 minus plus 5 is 135 minus 5n equals to 0. Now for this to be 0, the inside term should be 0. Perfect. So for this to be 0, this portion should be 0. So what we get here is that 135 minus 5n should be equal to 0. That means 5n equals to 135, or n equals to 135 divided by 5. Clear? So 5 times 2 is 10, 35 is 7. So n is 27. So the answer is 27 terms. So if we have 27 terms in this particular arithmetic progression, then the total sum is going to be 0, right? So that is what it means. So I hope this set of 6 questions help you to understand the basic concepts of arithmetic progression. We'll actually take up level 2 questions based on arithmetic progressions in the next video. Hope you get a good start from this set of examples. Feel free to share your views and your comments, and if you share my videos with your friends, that will be great. Thanks for watching and all the best.